Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. So I welcome you all to this platform of Unacademy. Okay, so before starting the lecture, let me give a brief introduction about myself. My name is Vidyapati Kumar, and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR, Central Institute of Mining and Fuel Research, qualified GATE twice, and I'm the author and co-author of various research papers publication of national and international journal of repute. You can Google about my works if you want to read the research works. You can follow me at unacademy.com at the rate of v.kesar, where after following me, you will be notified whenever I will be scheduling any new courses, new videos, you will be getting notified at the same time. So basically, in this session, we are going to focus the numerical aspects. We are going to focus on the numerical aspect of extrusion and the wire drawing. So in the earlier classes, we have covered the maximum theory. We have covered the maximum theories and the few numericals also. Okay, so basically in this session, we are going to dedicate a very good time to the numericals, and I have brought a very good collection of the numericals for you, so that uh, after attending this lesson you will be very much comfortable in these chapter. Guarantee you will be very much comfortable in handling all the questions which are related to the extrusions and the wire drawing without any doubt. So before starting, if you have not downloaded the Unacademy learning app, download the Unacademy learning app, as there is a free classes which I take, that is the special classes from 10 a.m. that is of strength of material. So you can follow me there, and definitely you can watch my whole course, full course of strength of material for GATE 2021. And there is a paid section. There is a paid section, that is the plus subscription. So what are the benefits of this Unacademy learning app? Daily live classes would be there. So definitely you will be interacting with your educator, and courses are structured in nature. It is not like the YouTube. Tests and quizzes you will be given, and the unlimited access of the course content materials are there. If you have not enrolled in the plus subscription, enroll it now, as it is totally worth it. 100% coverage of the syllabus would be there. Entire syllabus would be covered, as well as daily live classes are there. So always you will be interacting with your educator. Any doubt will be there, definitely you will be resolved, your doubt will be resolved at the same time. Courses are structured in nature. कोर्सेज जो है इस तरह से डिजाइन किया गया है ताकि आप बेहतरीन तरीके से चीजों को छोटे से छोटे तरीके से आप समझते जाएं. Test and quizzes you will be given for the practice, and unlimited access of the course content materials are definitely there. There is another subscription that is known as iconic subscription. The benefit that you in this iconic subscription is that you will be getting all the benefit of the plus. Apart from the benefit of the plus, you will be choosing any of your educator to be your personal coach, and that educator is liable to help you throughout your preparation of GATE and ESE. That will mentor you, that will guide you whenever you will be stuck in your GATE preparation or the ESE preparation. That educator will also track your study, will make a personalized test analysis, so that educator will like guide you one-on-one basis. And definitely whenever you are committing any such mistakes in your test and the practice test, you can always reach out to them, and you will be getting a lot of benefits on there. So basically you are getting the personal coach, you are getting the personalized test analysis, study planner would be there, preparatory study materials would be there, PDFs would be there. So you will be having the PDFs and the other study materials which are relevant to your study. Everything would be provided in this iconic subscription, apart from the plus benefits whatever you are getting. So these are the top educators, and definitely you can learn with the top educators at the same time enrolling in a course. So there are a lot of batches which are for the dedicated for the GATE and ESE, which has already been started in the month of October and the November, है ना. बहुत ही जल्दी से टाइम बाउंड ये सब कोर्सेज स्टार्ट हुए हैं, and definitely you can go and join these courses for mechanical, civil, electrical, electronics, production, industrial, so on and so forth. But definitely, whichever is your branch, you can always go and check out those things, and you can always recommend to your friends, to your peers, to join the courses that as such as the rank booster courses are there, target ESC prelims are there for the mechanical, for the batch A, batch B. A lot of batches are there for the different branches. For the gate preparation 90 days, uh, for the prelims civil, for the mechanical rapid revision batch tests are there. So for example, the doubt clearing batches are also there, for the chemicals also there. So for each and every branches there are a lot of batches. You can go and check out these batches as per your need. And whenever you are going for the plus subscription, suppose for a 1 month it is costing around 5,500, for a 12 month it is costing around 30,250, and for these are the for the 18 months and 24 months. So those who are in second year or in third year, they can always go and subscribe to these things as per their need. And whenever you are subscribing to the plus subscription, use my code SIRVK to get the 10% off and to get my personal mentorship. So suppose for example, if you are subscribing for a 12 months, so after using my code, that is the SIRVK, the amount would be 27,225. Similarly, for the iconic subscription, these are the prices, and use my code SIRVK to get a 10% off. Okay. So let's start our discussion of the extrusion and the wire drawing. We are going to start the numericals, a lot of numericals. But before starting the numericals, let me check the comment box first. Okay. So let us start our discussion of the numericals, what we are going to do it. Before starting, let me give you again the formula sheet, whatever I have given to you. Okay. I'm going to make you revise whatever the formulas we have seen till throughout the discussions of the wire drawing and the extrusion. So just a quick recap to you. We have seen that for the extrusion, basically the assumption was what? Uniform deformation is there and friction is absent. Okay, friction is absent. And basically for these cases, we have seen that if I want to find the force required in the extrusion, which is given by P is equal to sigma F into A naught into ln of A naught by AF. We have seen this formula. Now see here, what is the sigma F? Very quickly I'm writing here. What is the sigma F? So basically the sigma F is the average flow stress of material. And we have also seen that this A naught by AF, can be written as sigma F. A naught will be pi by 4 d naught square into ln of A naught can be written here as pi by 4 d naught square pi by 4 df square. If you could remember that, what is the figure? Let me draw the figure here. Suppose there is an extrusion process, and in this extrusion process, what is there? This is a billet. Suppose this is a billet, and here is a padding. So here is a padding. So here is a padding. This is a padding, and from here you are applying a force. Okay. So from here you are applying a force. So you are applying a force like this, and there is a small opening, orifice opening is there. From this the extruded metal is coming out. So initially the diameter of the billet is given by the d naught, and the final diameter, that is the material that is getting extruded out, its diameter is df, that is denoted by here. So d naught and df are the initial and the final part of the material. So when you will work out these things, you will be getting this formula, that P is equal to sigma F would be there pi by 4 d naught square, and this will be ln d naught by df square. Okay, now see, d naught by df square can also be written like this, that is twice of sigma f into pi by 4 d naught square into ln d naught by df. Now you also know that there is a naught by af. This a naught by af is there, and do you remember that I have told you there is an extrusion ratio? There is a extrusion ratio, so this formula can also be written as sigma f into pi by 4 d naught square into ln of r. What is the r? So basically r is the extrusion ratio. So these are the formulas that we have really discussed in our earlier section. So what you need to remember, what exactly is the key takeaway point from here? That is the extrusion force is given by this formula. Okay, by this formula. Okay, this is the formula that is most important. Now based upon this formula, we have seen that it is also written like that. It is also written like that, as well as it is also written like that. ठीक है, तो these are the way in which this formula is molded. तो इन सब चीजों को आपको याद रखना है. Okay, good evening Subham Raj. Hello Mohammed ji. Now see here, these are for the ideal conditions. Okay, these are for the ideal conditions. Now suppose we are talking about the real conditions. So for the real conditions, for real conditions, what exactly is the difference? That is the average flow stress is equal to K, where this K is known as extrusion constant. Extrusion constant. Okay, now see here, we have talked about the forces. Okay, we have talked about the forces. See here, we have talked about the forces. Okay, we have talked about the forces. That is, the extrusion force will be what, right? Extrusion force like this, formula 1, formula 2, formula 3. We have talked about the extrusion forces. Let us talk about the stresses. What are the stresses that is going to act here? So if we talk about the stress, so how can we find the extrusion stress? See here, sigma extrusion. So you can write this like that, which is what? Forces which has been applied. And see here, my dear friend, you are actually applying the force on the initial area. See here, this is the initial area. Okay, and the cross-sectional area for this will be what? This will be final area. So basically you are applying the forces on the initial area. Okay, now so that is the reason you are multiplying by the a naught. You are multiplying by the pi by 4 d naught square. You are multiplying by the d naught square. This is the one way to remember that in extrusion I am applying the forces in the initial part, and hence these are the formulas. Now we are writing p by a naught, which is nothing but sigma f into ln of a naught by af. And again you can write like that, sigma extrusion, which will be given by sigma f into ln of r, where r is what? Extrusion constant. And this is also written as a sigma extrusion is equal to twice sigma f ln of d naught by df. So these are the way in which I have written the formulas. Basically main formula तो आपका यही है, but it is derived in terms of extrusion ratio, in terms of diameter. ठीक है, क्वेश्चंस में डायरेक्टली ये सब दिए जाते हैं, तो knowing these formulas will be very much helpful for you. Now if we talk about for the real conditions, Then for the real condition, you will have the sigma f is equal to k, where k is the extrusion constant. So I hope you have understood the each and every formula of the extrusion. Okay, for the extrusion. Now let us talk about the formulas for the drawing, for the wire drawing. Hello Anmol ji, hello everyone. तो चलिए ड्राइंग के बारे में समझते हैं फॉर द वायर ड्राइंग. Now for the wire drawing, again the assumption is there. What are the assumptions we have seen? We have seen that it is for a uniform deformation and friction is 0. Okay, that is the friction is absent. Now for these cases we have seen that forces would be sigma f into af. Why af? Because we are actually pulling the system from the final area. Okay, आपको याद होगा, that is the ln a naught by af. Now this is also written as P is equal to twice sigma f pi by 4 df square ln of d naught by df. Just the same thing that we have repeated in the extrusion. And if we talk about the stresses, we have talked about the force. So what is the stress? So sigma drawing would be given by P by AF, which is nothing but sigma F ln of A naught by AF, which is again written as twice sigma F ln d naught by df. So I hope you have understood each and every aspects of the formula, whatever I have written to you, and definitely each and everything is clear to you. Now, if these things are clear to you, please try to solve this question which has been asked in GATE 2008 for the production engineering paper. Please try to solve this question. And tell me the answer. Please try to solve this question and tell me the answer of this question. Give a try whether you are committing the mistakes or you are committing the you are giving the right answer. That's not a problem. Even if you are committing the mistake, you are actually going to learn it. Okay, so I have got an answer from Narendra ji, that is the 357. Okay, what about others? My dear friend? What about others? See, simple question is there, whatever the formulas I have discussed you, है ना. देखिए, ये जो भी फॉर्मूला मैंने आपको डिस्कस किया ना एक्सट्रूजन का, ये देखिए एक्सट्रूजन की फॉर्मूला हमने डिस्कस की है, that is extrusion, and we have also discussed the formulas for the wire drawing. So these whatever the formula sheet I have given to you, if everything is known to you, you will be able to solve this question. You need not have to refer any other thing, whatever I am telling to you. If you are understanding, then you are able to solve the question, definitely. What about others? Okay, let me explain this question so that if you are in a dilemma that you do not understand the question, don't worry. There is a 10 mm diameter. So a 10 mm diameter annealed steel wire is drawn from the dia at a speed of 0.5 meter per second to reduce the diameter by 20%. So what exactly is there? So this is the process. So the yield stress of material is 800 megapascal, neglecting the friction and the strain hardening the stress required for the drawing operations. So basically in the drawing operation, what exactly is there? So this is a die, this is a die, and this is the die, and from here you are giving the wire. So there is a wire diameter is what? Wire diameter is, in this case it is a 10 mm. So this is the 10 mm. Now it is reduced by the 20%. So the wire which is coming out from here, the wire which is coming out from the here, that will be reduced by the 20%. So if it is reduced by the 20%, it simply means that it will be 10 mm. So it will be 0.8 of 10 mm. That is, if 20% is reduced, that is the 80% is there. 80% is there. Okay, so if 80% is there, that is what? That is 8 mm. That is 8 mm. Fine. Now, so this is 8 mm given to you. This is 10 mm given to you, and it is drawn through a speed. So this is the speed which is given. So speed is given is what? So speed which is in drawing, that is the 0.5 meter per second. Okay, this is the speed by which it is drawn. Okay, it is drawn. So you need to find the stresses required. So how you can find the stress? So stress is given by, so stress of drawing is given by sigma f ln of a naught by af. Now I can write this formula as sigma f ln of d naught by df twice. And see, I know the sigma f. What is the sigma f? That is given in this question is 800 megapascal yield stress of the material. So whatever the material is there, uska flow stress ye diya hua hai. So you can write it here, that is the twice sigma f is given by 800 into ln of 10 mm by 8 mm, and you are going to find the drawing stress, and the drawing stress would be coming to be around 357 megapascal. 357 megapascal. So Narendra ji has given a correct answer. Very good, very good. So this is your answer. Please try to solve this question. This is a linked question that has been asked, and this linked question, it has been asked to find the power. It has been asked to find the power required for the drawing process. Okay, so what is the power? If you go into the basics, of the power, so basically the power is given by drawing force into the velocity by which this material has been drawn. And in this case, we can say that power, what is the drawing force? How you can find the drawing force? Just now you have calculated the drawing stress. Now see, you know that you are applying this stress is actually applied in the final area, on the final area. Yes or no? So I can write that power would be P of, so basically it is sigma d. Just now we have found the sigma d. We are going to multiply by the final area, and there is a velocity that we are going to multiply it. Then we are going to find the power. So what is the power? So what is the sigma? Sigma is 357 megapascal. So put it here, that is the 357 Newton per millimeter square into what is the area? So see here, what is the final area we have seen? This diameter is 8 mm. Clear? So final area will be what? This is the cross section, so pi by 4, 8 square would be there. Clear? So we can write it here is pi by 4 8 square, which is nothing but mm square. What is the velocity? In this case, if you could see here, the velocity by which it is being pulled is 0.5 meter per second. So just put it here as 0.5 meter per second. And see here, these are in mm square, so you can say that this mm square will get cancelled out, and hence you will be getting the power as 8.97 kilo. That is the option A. That is the option A. So I hope you have understood this question. Any doubt in these two questions? Any doubt in these two questions? Dheeraj ji, I think you are asking this question 4 or 5 times. This is the 5th time or the 4th time you have asked this question. And each and every time I have given you the same reply that I am going to say again and again. Yes, I am going to complete it. Okay. I have already completed the metal cutting, and in the near future, I am going to teach you the advanced machining and the machine tools also. Okay. जल्दी से मैं आपको कंप्लीट भी कर दूंगा. मेटल कटिंग मैं ऑलरेडी कंप्लीट कर चुका हूं. ठीक है, चलिए. नरेंद्र जी हैज गिवन 8.9. वेरी गुड, वेरी गुड, वेरी गुड. Actually try to solve the question, and even if you are not able to solve it, then I will solve it. Okay, तो घबराना नहीं है क्वेश्चन सॉल्व करने से. Try to tell the answer, try to find the answer of this question which has been asked in ESE 1996. Okay, what would be the answer? Can you tell me? Can you tell me? Please try to respond the answer of this question. Please try to respond the answer of this question. See, you do not know this blanking operation. Okay, from the tomorrow sessions, from the tomorrow onwards, I am going to teach you the sheet metal operations, and basically this is in the sheet metal operations. Sheet metal operation. Okay, so I have got an answer from Narendra ji, Suvam Raj, CA. Okay, what about others? What about others? Do not hesitate to give the answer, because your active participation would really motivate me to make you understand in a very good way, in a very lucid way. Okay, आपका पार्टिसिपेशन नीड होता है इसमें. चलिए, कोई बात नहीं है. See here, the wire drawing. In the wire drawing, see here, in the wire drawing, this is the wire drawing process. See, I've already drawn it. So this is a wire drawing process. So this is a wire drawing process. Now, in the wire drawing process, you can understand that there is a tensile force. With the tensile force, you are actually pulling this material. Okay, so there is a die. Suppose there is a die, and this is the final part which is getting out of the after the wire drawing. So you are pulling it. You are pulling it. So what is happening there? So whenever you are pulling it, there would be a tensile force. There would be a tensile stress which is coming into the picture. Okay, so in this given thing which has been given, that is you can understand that there is a wire drawing process. Okay, so there is a wire drawing process. In the wire drawing process, tensile force will be coming. Okay, tensile force will be coming. Now let us talk about the extrusion. Now see, in the extrusion we have seen, see here, in the extrusion figure also I have drawn it. So in the extrusion, what is happening? This entire part is what? Compressed. See here, there is a compressive force. There is a compressive force which is coming into the picture, like this. So entire section is being compressed, and hence what we can say here. I have discussed these things, but again I am just explaining it. So in the extrusion, compressive force would be there. And by knowing only and only these two things, you are in a great position to answer the question. That is, A will be 2, B will be 3, and hence option C would be the answer. Now, those who have watched my each and every videos, then you are knowing that I have talked about the spring back effect. Do you remember it? The spring back effect. So in the spring back effect, we have seen that if there is a die like that, and in this die, whatever you are doing, there is a sheet, and you try to bend this material. If you try to bend this material, then what will be happening? The sheet will be taking this kind of shape, and after that, it is going to, like, going back into this original configuration. So in this case, spring back force will be acting. So this is a case in which you are going for the bending. Okay, for the bending you are getting the spring back effect. So only by knowing these data, you are in a very great position to solve this question, and hence option C is the correct answer. So I have got answer from Narinder, so that is the C, correct answer. So I hope those who have given the wrong answer, they have totally understood this question. Okay, try to solve this question. 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 How much force will approximately be required to draw a wire from 1.5 mm diameter steel wire to 1 mm diameter? Clear? So earlier there was D naught was 1.5 mm. So D naught is 1.5 mm and DF is 1 mm. If the average yield strength of the work material is 300 megapascal, clear, that is the average strength is given, that is the given here is sigma F, 300 Newton per millimeter square. Now you need to find the force, how much force will be required to draw. So find the force required for the drawing. Tell me the answer. So I've got the answer from Varun, that is the B. Okay, what about others? What about others? And Varun, could you check your answer once again? Because there might be some discrepancy in your calculations. Could you check your answer once again? How to find the drawing force? Again, the simple thing is there. How you can find the drawing force? I have explained it. See here. For the wire drawing, apply this formula. Sigma F AF into ln A naught by AF. Clear? So, just apply it. Sigma F AF ln of A naught by AF. So what is the sigma F? That is the 300 Newton per millimeter square. What is the AF? That is the pi by 4 1 square, that is the mm square, into ln of A naught by AF. What is the A naught? That is the 1.5 mm square is there. So just to put it here like that, pi by 4 1.5 whole square by pi by 4 1 square. Try to solve this question. Now tell me the answer. What is the answer that you are getting here? Now tell me the answer that you are getting here in this case. You can directly apply this formula also. You can directly apply this formula also. What I have told you, that is the P is equal to 2 into sigma F into AF into ln D naught by AF. Okay. And then only you can also get the answer. Please tell me the answer, whatever the answer you are getting from this. What is the answer that you are getting? The answer that you will be getting, that would be around 191 Newton. 191 Newton, isn't it? So the answer that will be approximate near to the 191 Newton, that is the 190 Newton, and the answer is A. Any confusion in this question? Any doubt in this question? Is there any doubt in this question? Subirji, don't worry about the question level. I am taking a lot of good questions. Or keep patience with me and stick with me. I have a very good questions. ठीक है, मैं increase कर रहा हूँ. Why not 195? Why will be 195? See here. See here, always see whenever you are going for the MCQ questions. MCQ questions में यही प्रॉब्लम होता है आपका कि जो भी आंसर्स जो है ना उसके नियर अबाउट जो होगा वही आप लें. ठीक है, 195 नहीं होगा आंसर क्योंकि इट इज बहुत ज्यादा वो. सी हियर 191 and 195 नियर अबाउट आंसर यू ऑलवेज टेक इट. नियर अबाउट आंसर यू ऑलवेज टेक इट. ठीक है, try to solve this question. Try to solve this question. K 2001, and it was also asked in the PI also. Same question has been repeated. Same question has been repeated. And I have explained this question. In my earlier lectures. In my earlier lectures, I have explained this question and the answers would be known to you. Please tell me. Why it is based on the final dimension? Previous question. Okay, for that you have to understand the basic physics, basic science of the extrusion process, and I have explained these things a lot of time in my earlier lectures. So I would recommend you to watch my each and every lecture. But for you, again, I am telling you, my dear friend, see here. What is the wire drawing? See here, what is the wire drawing? So basically in this wire drawing, see here, basically in this wire drawing, so this is a wire drawing process. So you are pulling this wire. See here, this is the wire, this is a wire. So like this. This is the final wire that you are getting from the final dimension. So see, you are pulling this wire, you are pulling this wire from this direction. So basically you are applying the force on the final dimension. Okay, final dimension in case of wire drawing. But in case of extrusion, see, you are pushing it, you are giving a compressive force on the initial diameter of the billet, that is the initial section. So for this reason we are using, since the force is applied in the initial section, hence there is a naught for the extrusion process, and since there is the force which is applied in the final dimension in case of a wire drawing, hence we take the final area. Clear? Okay, so we have got the answers. B, Harish ji has told B. Very good, Harish ji. Very good. So I have explained this thing, that is so maximum possible reduction in case of wire drawing. So how we can find the maximum possible reduction in case of wire drawing? So basically I have explained you, that is the sigma D is equal to sigma F ln of A naught by AF. Clear? And I have explained you that for the maximum possible reduction, sigma D will be is equal to sigma F for maximum possible reduction. So if this is the case, you can understand that sigma f is equal to sigma f ln of a naught by af. Clear? So from here you can say that sigma f will be cancelled out. So you are left with a naught by af is equal to e. Okay, so a naught by af is equal to e, and from here the value of e is what? 2.182. Now see, there is a reduction. They are asking about the reductions. So see here, the reduction, the percentage reduction that you can find. So here you not need to find the percentage reduction. What is the reduction? So a naught by af by a naught. This is the reduction. So basically you can find 1 minus of af by a naught, which is, see, what is the af by a naught? Just now you have calculated that this is e. So this is 1 by e. So this is going to be is equal to 1 by 1 minus of 1 by e. So if you will work out this, it will be coming around 0.63. So the answer that will be option B. So definitely Sameer has given the correct answer and Haris has given the correct answer. Very good, very good. See, again this was the question which was asked in GATE 2001, GATE 2007. Now the same question which has been asked in GATE 2018. See, the same question was asked in GATE 2018, but the question was framed in a very different manner. See, the question was framed, the maximum reduction in the cross-sectional area per pass, that is the R, of a cold wire drawing process is given by this, where N represents the strain hardening coefficient. Now see, these each and everything is given. Okay, for the case of a perfectly plastic material, then R is what? So in this question, there was an attempt to mislead you. So only the thing that you should focus is this. That they are asking about the maximum reduction in cross-sectional area. So maximum reduction in the cross-sectional area in the wire drawing process. This is only thing that is required for throughout your understanding. And if that is the thing, you will be able to understand that option D is the correct answer, 0.632. Clear? And this is the same question that has been asked. Please try to tell the answer of this question. What would be the answer? Same question is there. Again, the same question is there. EAC 2014, in a wire drawing operation, maximum reduction per pass for the perfectly plastic material in the ideal condition is what? Is B. Option B. That is a 63%. So I hope you are understanding these questions. Now try to solve this question. No hurries, that should be B. Okay. Try to solve this question. GATE 1996. Try to solve this question. I'm giving you some time. Please try to solve this question and then tell me the answer. This was the very good question which has been asked in GATE 1996. So basically, if you could understand this question, a wire of 0.1 mm diameter. So there is a diameter of the wire. This is 0.1 mm. What I need to repeat, Nikul? Please explicitly mention what should I repeat it, because I cannot understand what exactly you need. What are the things that you need from my side to get repeated? Please tell me once again. And for those who, please try to solve this question. GATE 1996 question is there. Please try to solve this question and tell me the answer. See here, for those who have done my classes, those who are in regular in my classes, so you are knowing that for the maximum possible reductions we have seen that sigma d is equal to sigma f for the maximum possible reduction, and from here we are getting a naught by af is equal to e, and for this we have seen that it is 0.63, that is the 63 percentage. Okay, we have seen these things, and in the question, in this question also it has been asked to find the maximum reduction in cross sectional area, that is again 0.632, and again in this question also it has been told to find the maximum reduction per pass for a wire drawing operation, and hence this is also 63%. Okay, so I hope you understood it. Now please try to solve this question. GATE 1996 question is there. Please try to solve this question and tell me the answer. See, if you are if you are means like अगर आप regular है मेरे videos में, then definitely I'm pretty much sure that you will not have any confusion, any doubt in solving the questions. Okay. Please tell me the answer. The wire of 0.1 mm diameter is drawn from the rod of 15 mm diameter. So what is the meaning? So there is a wire. There is a wire, and the length of the wire is what? So this is the diameter. So diameter is 15 mm. Okay. Now in the wire drawing operation, after drawing this wire, so the diameter of the wire is made to be this. And what is its diameter? It is 0.1 mm. So in this question, it has been told that die is giving the reductions of 20%. So basically there is a die. So there is a die. So this die, one die gives a 20% reduction, another die gives a 40% reduction, another die gives a 80% reduction. Clear? Now they are asking that for the minimum error in the final size, number of stages and the reduction at each stage respectively would be what? So which option is going to be correct? So can you solve this question? Just let me know. If you can solve this question, then that is good. Otherwise I am going to proceed it. Please let me know. Please let me know. Should I proceed it? Okay, so I'm assuming that I'm proceeding it. See here, in the first option it is given that try to solve this question by the option. Okay, so in the first option it has been told this is the 3 stages, and in the 3 stages you are using the 80% reduction for all the 3 stages. Okay, so basically try to understand that if, so this is an option A, so I'm just solving for the option A. What it has been told? It has been told that you are using 3 stages, and for the each stages there is an 80% reduction. So 3 stages are there and 80% reduction is there. Okay, so Subhasis has given the answer A. Okay, please see here, Subhasis. Definitely you will be able to understand what is the mistake that you have done. Okay, see here. So if there is an option A, we are going with the options. Okay, and then we are coming to the conclusion. So in the option A, it has been told 3 stages are there and 80% reductions are there. Now see, so earlier you are having the 15 mm diameter, yes or no? So you are having the 15 mm diameter. Clear? So this is the D naught that you have, and this is the DF. Okay, so Khyati has given the option B. Very good, Khyati. So see here, so this is the D naught which is given, and this is the DF which is given. So can I say that 15 mm reduction is there? Now in the first pass, in the first stage, you are giving the 80% reduction. So meaning of 80% reduction means what? Basically 20% is there. अगर आप किसी भी चीज में से 80% रिड्यूस कर रहे हैं तो 20% ही तो होगी आपके पास, and hence what we can say here 15 mm minus of 0.8. This is the thing. So this is you are getting in the first stage. Clear? This is you are getting in the first stage. Clear? Now in the second stage, this is the diameter. Clear? This is the diameter. This is the diameter that you are going to get for the first stage. Now for the second stage you are getting it again. You are using a 80% reduction diameter, so you will be getting like this. So this is for the second stage. Okay. Now D3 in the third stage. In the third stage, what is there? 15 mm will again be reduced by the 80%. Okay, so 1 minus of 0.8, 1 minus of 0.8, again 1 minus of 0.8. So this is happening for the third stage. So in the option, it has been told that from the third stages, so if you will be calculated D3, so D3 will be coming around 0.12 mm. Now understand, if you will try to find the error, so error will be coming around 0.02, but you did not have to worry about error. I will tell you why. So this is the option A. This is the option A conclusion that we have seen. Now let us move to the option B. So in the option B, it has been told 4 stages are there and 80% reduction for the first 3 stages, followed by finishing stage of 20% reduction. Clear? So basically in this question it has been told कि सर आपको 4 स्टेज लेना है, 4 स्टेज में 3 स्टेज में आपने 80% रिड्यूस करना है, and after that you have to go for the 20% reductions. Okay, so let us talk about the B. So in the B it has been told that you go for the reduction. So what will be the final? So final would be 15 mm. First stage will be 1 minus 0.8. Second stage will be 1 minus of 0.8. Third stage will be 1 minus of 0.8. Now after that, see, it is similar to this, but what is the difference? There is a 20% reduction would be there at the final stage. So if there is a 20% reduction at the final stage, I am going to multiply by 1 minus of 0.2. Okay, now from here you will be getting the DF as 0.096 mm. Okay, 0.096 mm. Now let us talk about the option C. What is being told here? 5 stages of reduction you are going to take it, and the reductions will be like that: 80% reduction in the first, second 80%, third 40, fourth 40, and fifth 20. So if that is the case, your final will be what? 15 mm, 1 minus of 0.8, again 1 minus of 0.8, because 80% reductions are there, 2. So for the 2 stages 80%, next what? 40 40, next 20. So multiply it: 1 minus of 40, 1 minus of 40, 1 minus of 20. So now if you will do it, you will be understanding that DF will be coming around 0.1728 mm. Now see here, आपका एम क्या था? What is your aim? To find the D naught to DF. So DF is around 0.1 mm. So in the all the 3 options you can understand this is 0.12. So error is 0.02. This is 0.096. So this is very much near. This is very much near to 1 mm. That is the 0.1 mm. Clear? So we are going to take this option B. We do not have to calculate the error. आपको एरर कैलकुलेट भी नहीं करना होगा, फिर भी आप कह सकते हैं कि ऑप्शन बी आपका करेक्ट होगा, बिकॉज सी इट इज नॉट नियर टू 0.1. So from these things you can say that option B will be the correct answer. Okay, and you can always go for the calculating the errors, and hence you will be getting the answers. Okay, so definitely Subhasis, I think you have understood your mistakes. Please try to solve this question. GATE 2015. Please try to solve this question. 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 This question which has been asked in GATE 2015. So basically in a two-stage wire drawing operation, a fractional reduction. Okay, so fractional reduction is given. And what is the meaning of fractional reduction? Ratio of change in the cross-sectional area to the initial cross-sectional area. So this is what is the meaning of the fractional reduction, which has been explicitly mentioned in the question. So in the first stage it is 0.4. The fractional reduction in the second stage is 0.3. So basically they are asking about if there is in the first stage the reduction is 0.4 and in the second stage fractional reduction is 0.3, then tell me the overall reduction. Okay, so Suvasis has calculated 0.58. Very good, very good. Nickel point. Okay, very good. Nickel, Khyati, Suvasis, very good, very good. What about others? What about others? So see, there is a shortcut also to solve this question. There is a shortcut also, but definitely first of all I will explain this question in a very detailed way, and then I will try to tell you answer in the shortcut way. But the problem with the shortcut is that maybe most of you may not understand this shortcut, but there is a I will try to make you understand. Okay, कुछ लोगों को problem हो सकता है. Okay, see here. In the first stage, the first fractional reduction says that it is 0.4. It is 0.4. So let me write it here. So the first fractional reduction is telling that what is the meaning of fractional reduction? That is the A naught minus the A1 by the A naught is equal to what? It is 0.4. So basically what is the A naught? A naught is the initial area. And what is A1? A1 is the area after first stage. So this is A naught minus A1 by A naught is given as 0.4. So from here you can very easily say that A naught minus A1 is equal to 0.4 A naught, and definitely from here A1 is 0.6 A naught. Okay, now see here, if we talk about the second fractional reduction, then what is being told in here? In the question it has been told that the second fractional reduction is 0.3. Okay, so what is the meaning of second fractional reduction? So it means that this A1 minus of A2 by A1. Clear? So let us say that A2 is what? Area after second stage. Okay, so this is given as 0.3. So from here you can say that A1 minus of A2 is 0.3 A1, which is A2 will be is equal to 0.7 A1. Clear? Now see, you have calculated that A1 is what? 0.6 A naught. Put it here. So whenever you will be putting it here, you will be getting as A2 is equal to 0.7 into 0.6 A naught, which is nothing but A2 will be 0.42 A naught. 0.42 A naught. And see, A1 is 0.6 A naught, A2 is 0.42 A naught. So what is the difference? So overall reduction would be coming around A naught minus of A2 by A naught. And this is if you will be calculating it, so A naught will be A naught, and you have seen that what is the A2? A2 is, just now you have calculated, A2 is 0.42 A naught. So this is going to be 0.42 A naught by A naught, and from here you will be getting as 0.58 A naught by A naught. The answer is 0.58. So I hope you understood this question. Okay, I hope you understood this question. Now see here. I hope you understood this question. So basically, if you could visualize in this question, if you could visualize in this question, so in the first reduction is says that 40%. So there is a shortcut which I have told you. There is a shortcut. Try to understand it. If you cannot understand, that's not a problem. कोई दिक्कत नहीं है. देखिए, अगर ये आपको बोला है 40% reduction, so there is a 40% reduction. So there is a 40% reduction. So there is a 40% reduction. Assume that there is a one unit is there. तो 1 यूनिट का अगर आप 40% रिड्यूस करते हो तो 1 into 0.4 would be 0.4. Clear? Now if you are going for a 30% reduction, 30% reduction would be there. 30% reduction of what? See, 0.4 is there. 0.4 is there. So definitely you are going for the 0.6 is only there. 0.4 is the final, so you are going to reduce on the 0.6. That is actually coming around 0.6 into 0.3, which is 0.18, and hence from here you can say that reduction is around 0.5. Okay, try to solve this question. GATE 2018, which has been asked in GATE. In a two-pass wire drawing, there is a 40% reduction, and then there is a 30% reduction in the second pass. Overall reduction. So in this question, overall reduction has been asked. Find the overall reduction. Tell me the answer. Tell me the answer. What will be the overall reduction? Very good, very good, very good, very good, very good. So the answer is 58. 58% is the correct answer. Same question is there. ठीक है, सेम तरीके से क्वेश्चंस बनेगा. So I'm not going to give the solutions for this. Okay, this is the answer. Very good, very good. So Nicole, Khyati, very good. Now see, I have taken a question which is of ESE 2011, and in this there is a lot of things that I want to explain you. Okay, so before that, let me take some blank papers. Okay, just a minute, just a minute. So see here, we have seen the wire drawing operation, isn't it? We have seen the wire drawing operations. So before going into it, let me give you a quick recap of the wire drawing. For the wire drawing, we have seen that there is a term that is known as the back pull. Do you remember the back pull stresses, back pull forces we have discussed in the wire drawing? Do you remember it? Back pull stresses, back pull forces. So definitely the sigma d, that is the drawing stress. Drawing stress is given by sigma f into 1 plus b by b into 1 plus 1 minus of rf by r naught to the power of 2b plus of rf by r naught to the power of 2b into sigma b. Now what is the sigma b and what is these things? Let me write it. So sigma f is average flow stress of material. What is the B? B is mu cot alpha. And what is alpha? Basically the alpha is semi-die angle. Semi-die angle. So if you could remember, this is the die. This is the die. If this is the die, so this angle is alpha. This angle is alpha. And this is 2 alpha. Clear? So this is alpha is semi-die angle. What is the RF? What is the RF? So RF is the radius of the workpiece at exit. So basically you are feeding the wire from here. You are feeding the wire from here, and this is what? This is your die, and the wire is coming out like that. So this is what? This is the DF, and this is what? This is the D naught. So D naught will be R naught, means radius, and final radius like that. So this is the RF. This is the RF, and R naught will be radius of workpiece at entry. So we have seen these things. We have seen these things. Now we have also seen in this session also, what is the thing? We have seen that if in the question it has been told to find the maximum possible reduction. So if there is a case of a maximum possible reduction, so for the maximum possible reduction, what I need to do it? I understand that drawing stress would be is equal to flow stress, isn't it? So by doing these things, we are going to calculate it. Now understand, this is the stress. This is the stress due to when you are pulling it. So this is basically the when you are drawing it, this is the stress which is coming out, and this is the stress that is coming as a back pull stress. So let me write it here also. Sigma B is back pull stress. Do you remember these things? These things I have explained in a very great way. Now see, suppose in the question there is no case of a back pull. So if they have mentioned that there is no back pull will be 0. So what you can say? So back pull will be 0. So this is going to be 0. Okay. So if back pull is 0, then your sigma D, the drawing stress, will be sigma F 1 plus of B by B 1 minus of RF by R naught to the power of 2B. This is going to be your drawing stress. Okay, so based upon these things, this is the question which has been asked in ESE 2011, and this is a very good question, and by understanding this question, when I will be solving this question, your entire doubts, whatever the doubts, if you have any doubt, for example, in understanding these things, अभी तक अगर कुछ भी डाउट अगर आपके दिमाग में बच गया है, इस क्वेश्चन को सॉल्व करने के बाद आपका सारा डाउट खत्म हो जाएगा. Okay, for that reason I have taken this question, and definitely if you have any doubt, you can always ask with me. So I am working out this problem. Try to understand this problem. So at 12.5 mm diameter rod is to be reduced to 10 mm. Clear? So there is a diameter. So initial diameter is given as 12.5 mm. Clear? So I can write that initial diameter is given as 12.5 mm. Now it is reduced to 10 mm. So it is reduced to 10 mm. So final diameter is what? 10 mm. Clear? Now by a drawing, so basically this is a drawing process, and in this drawing process you are reducing the diameter. Yes, that is obvious. In a single pass. And what is the speed? So what is the speed by which you are pulling this wire? So you are pulling this wire with the speed of 100 mm, 100 meter per minute. Okay, this is the speed by which you are pulling the wire. Okay, now assuming a semi-die angle, always remember my dear friend, if in the question it has been told that this is a die angle, that is die angle will be what? Understand, again I am telling you, understand, again I am telling you, alpha is the semi-die angle. Alpha is the semi-die angle. If it would be happening like 2 alpha, then that will be die angle. Die angle. Okay, so always try to understand. So this is the semi dry angle, this is the semi diangle. So in this it is alpha is given as 5 degree. अगर वो डाई एंगल दिया रहता तो दैट इज 2 अल्फा, तो उस केस में अल्फा क्या हो जाता, 2 अल्फा अगर 5 हो जाता है तो अल्फा विल बी 5/2. रिमेंबर दीज थिंग्स, है ना, ये सब बेसिक्स हैं. And the coefficient of friction between the die and the tool is given as 0.5, 0.15. So that is the mu is equal to 0.15. Okay, now they are asking about the maximum power required in the drawing. Maximum power required in the drawing. Now see here, they have told that take stress of the work material to be 400 Newton per millimeter square. So what is the sigma F value? Sigma F value is given as 400 Newton millimeter square. Okay, so let us work out this problem. In this question it has been asked to find the power. So how we can find the power? So first of all we need to find the force. Okay, so what is the drawing force? What is the drawing stress? We have seen that it is nothing but sigma F 1 plus of B by B into 1 minus of RF by R naught to the power of 2B. This is the formula that we have seen. And if this is the formula we have seen, because back pull stress is what? Back pull stress is 0. There is nothing such thing as has been mentioned. So back pull will be 0. So this is the drawing stress. Now we have seen that sigma F is given in the question. That is what? Okay, before that, sigma F is given as what? This is 400 Newton per millimeter square. Now what is the B? See, B is nothing but that is mu cot alpha. Okay, so mu is given in the question 0.5, 0.15, alpha is 5. So put it here, that is the 0.15 cot of 5 degree. The B you will be coming, that will be coming around 1.7145. But this is the B. Now you have find out the B, just multiply it like that. 1 plus of 1.7145 by 1.7145 into 1 minus of RF by R naught. What is the RF? See, just now we have seen that DF is 10 mm, so RF will be 5, and D naught is 12.5 mm, so RF will be 6.25. So this will be 5 by 6.25 to the power of 2 into 1.7145. This will be, now just try to calculate it. Try to calculate the sigma D, and the sigma D that you will be coming, that will be coming around 338.653 megapascal. Now see, this is the drawing stress, but in the question it has been told to find the power. How to find the power? Power will be what? Power will be nothing. So power will be nothing. So first of all, power will be nothing, but that will be drawing force into velocity with which it is drawn. Now how to find the drawing force? This is the stress. So sigma D. Now this stress is acting in the final area. So it is acting on the final area, not the initial area. So we have to multiply by the AF, and the velocity is given in the question. So this is the power. This is how you can find the power. Now see, you have you know the sigma D, you know the AF will be what? So just let us try to work out this problem. So see here, the power will be what? Sigma D just now you have calculated that is 338.653 Newton per millimeter square. What is the AF? That is the final area, so that is the pi by 4 into DF square. What is the DF square? So if you could see here, the DF is 10 mm. Okay, the DF is 10 mm, so that is the 10 square. This is also in mm, so mm square will be there. Now what is the velocity by which it is pulled? See, the velocity by which this wire has been pulled, that is the 100 meter per minute. Meter per minute. Okay, so this is in meter per minute. To convert this in meter per minute to meter per second, what we need to do it? Can we write like that, that this is 100 by 60 meter per second? Yes or no? So I can write like that. Okay, so now if I can write like that, I will put it here. I will put it here. So the velocity will be 100 by 60 meter per second, isn't it? Now see here, let us check the units. So mm square will cancelled out, so you are left with Newton meter per second. Can you tell me what is the Newton meter per second? Can you tell me what is the Newton meter per second? So the power that is coming from this thing, the power that is coming from here, it is 44.329 kilo. ओके, ठीक है, तो यहां से आपने किलोवाट में आंसर निकाल लिया. सो दिस इज द पावर दैट यू आर गेटिंग. Now see here, so this is what is being asked, the power required in the drawing. So the power required in the entire drawing process is this. Clear? This is the entire drawing process. This is the power. Fine. Now it has been told that calculate the maximum possible reduction in diameter of the rod. Now see, अभी हमने इससे पहले केसेस में क्या देखा था? इससे पहले केसेस में अगर आप ध्यान दें, I have explicitly mentioned the things, but even if you have not focused the things, I have written. What is the thing that I have written? Sir, this is the condition. This is the condition for a wire drawing. Definitely. What is the assumption? Assumption is that uniform deformation would be there and friction is zero. Friction is zero. Clear? This is the assumptions that we have seen. Now in this wire drawing cases, we have seen that if we are taking into the consideration of the friction, so we have taken the consideration of the friction, and we have taken the again another consideration that we are applying the forces from the back side. So there is a back pull. So if there is a back pull, so these are the cases. For these cases, if I want to find the maximum possible reduction, how we can find the maximum possible reduction? So see here, so for the maximum possible reduction, for maximum possible reduction. Now for the maximum possible reduction, we have seen that my drawing stress would be is equal to flow stress, isn't it? I have explained the reason behind it, है ना? अगर इससे ज्यादा हो जाएगा तो हमारा वायर ब्रेक कर जाएगा. आप मेरे प्रीवियस वीडियोस को देख सकते हैं अगर आपको कहीं पे भी कोई भी चीज का डाउट होता है तो. ठीक है. Now see here, from this, what is the maximum possible reduction that you will be getting? Good evening, Ritesh. Good evening. Khyati has given the answer as 25.12. Okay. See here, Khyati, definitely you will be understanding. So sigma d is equal to sigma f, we have seen. Now just work out this thing. So sigma, to put it here, that sigma d is what? Sigma d is sigma f 1 plus b by b into 1 minus of rf by r naught. And there is a, just a minute, this is the to the power of 2b. And now see here, we have seen the sigma d value is equal to sigma f. Put it here, that is sigma f. Put it here, that is sigma f. You know the b value, just now we have calculated. So now if you would see here, the b value is what? B value, it is coming around 1.7145. In the previous we have seen. What is the rf? So see here, what is the r naught? See here, the r naught value is what? See, the r naught value is, this is 12.5 is the diameter. So what is the r naught? So r naught will be 6.25. So substituting these things, you will be understanding that rf, so rf, this will be coming around 4.67 mm. Final radius is coming around 4.6 mm. Now see here. What is the initial radius? 6.25. What is the final radius that you are coming? That is 4.67. So if you want to find the maximum possible reduction in diameter, so how you can find the maximum possible reduction in the diameter? That is nothing but d naught minus of df by d naught. Okay, so if you are talking about in 100, then this is in percentage. Now you can also replace it like that, r naught minus rf by r naught into 100, and put it here, that you will be getting, let's see here, r naught is what is the r naught value? This is 6.25. What is the rf? That is 4.67. Clear? So put it here, that is 6.25 minus 4.67 by 6.25 into 100, and this is coming to be around 25.3%. So very good, Khyati, you have calculated correct way. Very good. So this is the maximum possible reduction that we are getting. Clear? So now these things have been worked out. Maximum possible reduction in the diameter of the rod. Now see, the next part is telling that if the rod is subjected to a back pressure, okay, so there is a back pull is there, so if that is the case, so it is 50 Newton per millimeter square. Okay, then what would be the draw stress and the maximum possible reduction? Now see here, I'm not going to solve this case. I hope now you understood these things. अभी करना क्या है? करना यही है सर कि ये जो फॉर्मूला था ना, ये देखिए, ये जो फॉर्मूला था, इसमें हमने सिग्मा बी को यहाँ पर 0 कर दिया है ना. In this my sigma b was 0. Clear? This is the 0 thing, because back pull की cases थी नहीं. So now what you will do, you will take this into the consideration. Okay, so now you will take this into the consideration and put the sigma b, that is the sigma b, you will take it, and the value of sigma b is given as 50 MPa. Put it there, try to find the sigma d. So I am just writing the sigma d, so you will be getting the sigma d as 361.26 megapascal. Okay, from here you will get the rf will be 4.78 mm, and the maximum possible reduction in dia you will get as 23.5%. maximum possible reduction in area, if you want, that will be 41.5%. I'm not going to solve it because each and every step is same. And if you are telling me, if you want me to solve, then also you please tell me, then again I will solve it. Otherwise I'm going to proceed in the next questions. Any doubt till now? कोई फरमाइश है तो वो भी बता दें. I will try to say everything about it. So I am proceeding to the next question. Now try to solve this question, which has been asked in GATE 2018. Try to solve this question. GATE 2018. Try to solve this question. Shall I solve the earlier question जो मैंने छोड़ा है? क्या मैं उसको solve कर दूं क्या? अगर solve करना है तो वो भी मुझे बता दें. I will definitely solve it. But because since each and everything was same, so why to waste the time? And that's why I have skipped that part. If you want me to solve that question, definitely I will solve it, no problem. But I have given that is for you. I have explicitly mentioned each and every answers. Please try to solve this question, which has been asked in GATE 2018. ये क्वेश्चन बनेगा आपसे या नहीं बनेगा, ये मुझे बता दें। बहुत ही आसान क्वेश्चन है इसमें, जरा देखें। प्लीज ट्राई टू अंडरस्टैंड द क्वेश्चन फर्स्ट एंड देन यू विल बी अप्रिसिएटिंग दैट व्हाट एवर द कॉन्सेप्ट आई हैव टोल्ड यू माय डियर फ्रेंड, वो उससे ज्यादा है ही नहीं, उसी से आप सारा का सारा क्वेश्चंस को बना लीजिएगा। जरा देखते हैं इसमें। ए स्टील वायर इज ड्रॉन फ्रॉम द इनिशियल डायमीटर दैट इज द डी आई ऑफ 10 mm. Clear? So I'm writing here in the side that is the di is given as 10 mm. To final diameter f is coming around 7.5. Clear? Now what is the half cone angle, that is the alpha. So half cone angle is given as 5 degree. Okay, no problem. Alpha is given as 5 degree. Coefficient of friction is given as between the die and the wire is given as 0.1. Okay, put it here. Average of the initial and the final yield stress is given by 350 megapascal. So okay, so that is given as sigma y average is 350 megapascal. No problem. Now what is there? The equation for the drawing stress is given by this. Now see the difference between ESC and gate. So understand. ये देखिए, ये इससे पहले हमने सॉल्व किया था ESC का प्रॉब्लम। ESC ने आपको चुपचाप से बोल दिया भैया अब तुम पावर निकालो, आपको पावर निकालना है, मैक्सिमम पॉसिबल रिडक्शन निकालना है, बैक पुल दे दिया, आपके लाइफ को पूरा कॉम्प्लिकेटेड कर दिया। एंड सी हियर, they want you to remember these big formula, but in gate they do not want you to remember the formula. They are very good, they have given this formula to you, and they are telling that if this is the drawing stresses, from here you need to find the drawing stress. So here they are telling that drawing stress is sigma f. Do not confused with our means like notations. I have taken sigma f is the flow stress. Don't get confused. In this question it has been told that sigma f is the drawing stress. So work out as what is being mentioned in the question. So the drawing stress in megapascal required to carry out this operation is what? Now put these values in this equation. Put these values in this equation and try to work out and tell me the answer now. Now tell me the answer. Now tell me the answer to this question, please. I'm waiting for your reply. Each and everything is mentioned in the question. Please try to put these each and everything, plug in the figures in this question, in this formula, and try to find out the answer. Please tell me the answer. Okay, see here. Okay, so I'm waiting for like 10 to 12 seconds for your answers, and then only then after that I will proceed it. Okay, so see here. So these things have been mentioned. So sigma f is what? Sigma y average into 1 plus of mu cot alpha. These things have been written. Okay, into 1 minus of df by d naught. So 1 minus of df by di to the power of 2 mu cot alpha. Each and everything is given in the question, that is the di, df, alpha, mu, sigma average. Substitute it here. So you will be getting sigma f is equal to sigma y, that is 350 into 1 plus of 1 by of 0.1. Mu is given as 0.1. See, mu is given as 0.1. Alpha is 5 degree. Put it here. That is the cot of 5. 1 minus of what is df and what is di? That is the 7.5 mm and it is 10 mm. So 7.5 10 whole to the power of 2 mu is 0.1, cot alpha is cot 5. Find the answer and you will be getting the answer of sigma f is 316.25 megapascal. Okay, this is the answer. This is the answer. The drawing stress which is asked in this question is what? This is 316.25. Clear? It has been told to correct 2 decimal places, so that is the answer. See, this is the question which has been asked in GATE 2018. ठीक है, तो ये नहीं सोचना है, प्लीज डू नॉट ट्राई टू थिंक लाइक दैट कि सर ये तो ईएससी कन्वेंशनल का प्रॉब्लम था. ईएससी कन्वेंशनल का प्रॉब्लम मैं इसीलिए करवाया हूँ फॉर दैट अगर आपका कॉन्फिडेंस इस क्वेश्चन में आ जाता है ना, तो यू कैन सॉल्व एनीथिंग, यू कैन सॉल्व एनीथिंग. ओके, प्लीज ट्राई टू सॉल्व दिस क्वेश्चन. Please try to solve this question. GATE 2011. This question is there. Please try to solve this question. Please try to solve this question. Please try to solve this question. See, in this question, a multi-pass drawing operation. Okay, so there is a drawing operation and this is a multi-pass drawing operation. A round bar of 10 mm diameter, 100 mm length. Clear? So what is the initial diameter? That is the D naught is given as 10 mm. And what is the initial length? That is the L naught is what? 100 mm. Clear? This is the, so suppose this is a wire like that. Its length is what? L naught. And its diameter is what? D naught. Clear? This is the thing. Now, this is reduced in cross section by drawing it successfully through a series of 7 dies. So you are using the 7 dies to decrease its exit diameter. Fine. During each of these drawing operations, the reduction in the cross sectional area is 30%, 35%. So what is the meaning? That at each and every die, so suppose you are using the 7 dies you are using, so one die is actually giving the 35% reduction. Okay, so you are using the 7 dies, these things have been mentioned. Next is what? The yield strength of the material is given as 200 megapascal. You need to find the total true strain applied and the final length. What would be the final length after the wire drawing operation? Okay, so first thing that you should always remember that कि 7 डाइज से आप इसको गुजार रहे हैं. ठीक है, मतलब क्या? देयर इज अ डाई 1 है ना. ट्राई टू अंडरस्टैंड. दिस इज द वायर. दिस इज द डाई 1 is there. Again die 1, die 2, dot 7 dies are there. Now see, what would be the initial area? So it has been given that D naught is what? 10 mm, isn't it? So if D naught is 10 mm, you can find that pi by 4 D naught square, that is the pi by 4, 10 square, that is the mm square, that you will be getting as 78.54 mm square. Clear? This is the initial area. See here, this is the initial area of the wire. Now you are using the 7 dies. Now understand, after first pass, that is a die 1. You are using the die 1. Now when there is a die 1 die is there. So after first pass, what is happening? It has been told that sir, each and every die will give the 35% reduction. Reduction in what? Cross-sectional area. Mind it. So if there is a reduction in the cross-sectional area, so I can say that my 1 minus of 0.35 into A naught will be the final area. Clear? After the first pass, this is going to be your फाइनल एरिया, यस और नो, दिस इज गोइंग टू बी योर फाइनल एरिया। अभी देखिए अगर 35% आप रिड्यूस कर देते हैं तो 100 में से 35 को घटा दें, ठीक है, तो वही तो आपका होगा, मतलब 65% ही तो आपका बचेगा ना, दैट इज द थिंग। So now see, this is after the first pass. Now see, after second pass, if you are talking about after the second pass, that is अगर डाई 2 में चले जाए, डाई 2 में चले जाए, अगर मैं डाई 2 में चला जाता हूं तो यही यही आपका फाइनल मिलता है। इसमें आपका फिर से 35% का रिडक्शन होगा क्या, तो इसमें फिर से 35% का रिडक्शन होगा, मतलब ये तो पहले से था ही, इसमें और एक 35% का रिडक्शन होगा, इसमें और एक 35% का रिडक्शन होगा, मतलब सेकंड पास में, इन द सेकंड पास व्हाट इज बीइंग टोल्ड, इट हैज बीन टोल्ड दैट माय फाइनल एरिया विल बी व्हाट, 1 minus of 0.35 whole square into a naught. First pass, see here, first pass power 1, first pass power 1, second pass final area की power 2, and what are the dies, 7 dies are there, so can I say that after seventh reduction or the seventh pass, after seventh pass the area will be, that is the AF7, right, AF7 is what, this is 1 minus of 0.35 to the power of 7 into a naught, isn't it? This is going to be my final area, so I can find that AF will be, AF7 means like 7th pass, okay, but this is 1 minus of 0.35 to the power of 7 into a naught. What is the a naught, what is the a naught, a naught is 78.54, I will just put it here, 78.54 mm square. So I can say that AF after the 7th pass is coming to be around 3.85 mm square. Okay, now in the question it has been told to find the total true strain, how can you find the total true strain, how can you find the total true strain, so total true strain, so total strain is given by ln of a naught by AF. Clear? Now see, what is the a naught, so earlier area was 78.54 and now the area is 38.3.85, 3.85, so total strain would be epsilon t would be 3.02, 3.02. Clear? So definitely Khyati and Ahmad Saab, Nikul ji, very good. So you have given the option C. Very good, very good, very good. So this is the true strain that I am getting, that is the 3.02. That is the 3.02. So from this we can say that option A and option B is wrong. Okay, now only the option C and option D is there. What is being told? Final length. Try to find the final length. Now how we can find the final length? How we can find the final length? See here. So the final length. How you can find the final length? So one thing is there, I have told you volume consistency principle. What is the meaning of volume consistency principle? That before the deformation and after the deformation, volume would be remaining constant, whether the shape and the size is going to change, but eventually the volume before the deformation and after the deformation, this is going to be same, and hence what we can say that a naught into L naught is equal to AF into LF. Now what is the a naught? So we have seen that a naught is what, 78.54, so put it here, 78.54 mm square into what is L naught, that is the 100 mm. If you could remember, this is what is being told, that is the 100 mm, isn't it? Now what is the final area? So the final area is, this is the final area, this is 3.85, and what is the final length? You don't know. From here you can calculate this LF, and LF will be 2040 mm. So basically this is the true strain, this is the true strain, and this is the final length. Clear? So if you could see here in the question, दिस इज द ऑप्शन सी विच इज द करेक्ट आंसर. समझ में आया ये क्वेश्चन या नहीं आया? प्लीज टेल मी, हैव यू अंडरस्टूड दिस क्वेश्चन और नॉट? Have you understood this question or not? Very good quality of questions are there. Very good questions are there. Yes, Nicole, volume initial is equal to volume final. Very good, very good. चलिए चलिए एक और क्वेश्चन सॉल्व करते हैं. ट्राई टू सॉल्व दिस क्वेश्चन. द सेम क्वेश्चन इज देयर, गेट 2011 सेम क्वेश्चन इज देयर. In this it has been told to find the force required for drawing. Okay, force required for the drawing the bar through the first die. पहले डाई से जब मैं ड्रॉ करूंगा तो उस टाइम पर मुझे कितनी फोर्स की रिक्वायरमेंट होगी वह पूछा गया है. प्लीज ट्राई टू फाइंड आउट द आंसर. प्लीज ट्राई टू टेल मी द आंसर. व्हाट वुड बी द आंसर? आई एम एक्सपेक्टिंग योर रिप्लाई. Please tell me the answer. Everything is same, each and everything is same, but the difference is that in this the drawing force is being required. Drawing force, you need to calculate the drawing force. Okay, tell me the answer. What is the problem? नहीं बन रहा क्या क्वेश्चन? ड्राइंग फोर्स कैसे निकलता है? P is equal to sigma f af ln of a naught by af, है ना? यही तो होता है आंसर. यही तो होता है आंसर, है ना? Okay, so Mihir is giving the answer D, that is 4.3 kilo Newton. Okay, very good Mihir. After a long time you are replying. Means this is the first reply that I have got from you. Okay, so 4.3 kilonewton is the force. Just put it here. So P is equal to sigma f af and a naught by af. Clear? So what is the sigma f? In this question it has been told that sigma f is 200. Okay, so 200 megapascal is the given sigma f. Put it here, 200 Newton per millimeter square. So what is the final area? So we have calculated the final area. Okay, so just put it here. The final area, that is coming around 51 into ln of 78.54 by 51. This is going to be 4.40. Remember, they are not asking about from here you can calculate. See, from here you can calculate. This is after the first pass. This is coming to be 51. Okay, this is the thing. ठीक है, तो यहां से आपका 4.40 किलोमीटर आंसर आ जाएगा. आंसर वुड बी ऑप्शन वुड बी. ठीक है, तो these are the very good questions, very good quality questions are there. और इस क्वेश्चंस को करें एंड डेफिनेटली आफ्टर अटेंडिंग दिस सेशन आई एम प्रीटी मच श्योर आपका कोई डाउट बचेगा ही नहीं वायर ड्राइंग और एक्सट्रूजन्स के केसेस में. चलिए इस क्वेश्चन को सॉल्व करते हैं एंड देन वी आर गोइंग टू कंक्लूड आवर सेशन. ओके, प्लीज ट्राई टू सॉल्व दिस क्वेश्चन. Okay, so Nicole has also given the correct answer. Very good. And Sanket ji, I really try my level best to give the good content. Please try to solve this question. Please try to solve this question. GE 2014. This question was asked that the metal rod of length, initial length. So let us assume the initial length is given, is subjected to a drawing process. So metal rod which have the initial length L0 is subjected to a drawing process. The length of the rod at any instant is given by this. Clear? So where T is the time in minute, you need to find the true strain rate. Understand. This is the true strain, sigma T. Now, when you are dividing the sigma T by the time, okay, by the time, then you are getting the strain rate, that is denoted by epsilon T dot. Okay, please try to find the answer. Please try to find the answer. Nickel 0.69. Okay. Mihir L0 will be 1 by 3. Okay. But in this Nickel and Mihir, we need to find the true strain rate. True strain rate. Okay. True strain rate निकालना है. चलिए देखते हैं. Please see here. Please see here. Please see here. What is the true strain? What is the true strain? So what is the true strain? Okay, what is the true strain? So the true strain is given by, that is epsilon T, is what? Integration of change in length by the length. Now see, they are asking about that if at any instant this length is what? L0 into 1 plus of T square. So I would replace this as this would be, L would be what? L0 1 plus of T square. Now see here, if L is, suppose the L is L0 1 plus of T square. So what will be DL? DL will be what? DL will be what? DL will be here, that will be L0 into 0 plus 2T into dt, isn't it? So you will have the DL as L0 2T dt. So this is a DL, just you now calculate it, substitute here. This will be 2 T L0 into dt. So from here you can, these are the differentiation, basic things are there. So L0 and L0 will get cancelled out. So what is the thing that you are getting? So epsilon T, that is the true strain. True strain is coming to be around 2T dt by 1 plus of square. Clear? And this is the from 0 to T. So basically this is the true strain, है ना? यही तो true strain होता है. अभी देखिए कि यहाँ पर बोला गया है if the true strain rate, you need to find the true strain rate at the end of 1 minute. What is the true strain rate? First of all, try to understand what is the true strain rate. So suppose that if I want to find the true strain rate, I have told you true strain rate is nothing but it is, if I am differentiating this with respect to time, that is the true strain when it is differentiated with respect to time, then it is the true then it is the strain rate, Now what is this? If you will differentiate this upper term, you will be getting as 2T by 1 plus of T square, isn't it? 2T by 1 plus of T square. See, further you can write like that, ln of 1 plus of T square, and definitely you can get this answer, है ना? आपको यहाँ से भी मिल जाएगा. Now they are asking about to find the true strain rate at 1 minute, at the end of 1 minute. So you need to find the true strain rate at 1 minute. T is equal to 1 minute. So put it here, that you will be getting as epsilon T dot is equal to 2 into 1 by 1 plus of 1 square. You will be getting as 1. You will be getting as 1 per minute. Fine. So this is the true strain rate that you are getting. That is the answer would be 1. Fine. So I hope you understood this. And for the Bara classes, I want to say that please watch my each and every videos, so to get a proper knowledge. Because at a random, if you are coming and asking these questions, this is not a possible to make you understand the entire thing in a very short. Okay, I've explained each and everything. This is the question which is we are taking in this session. So please stick to the things. Please try to tell the answer of this. We have discussed the extrusion forces. Anna, please tell me the answer. Please tell me the answer. See, material of the die. Yes, we have seen these things. I hope you understand. Extrusion force is depending upon the extrusion ratio. Yes, we have seen that, है ना? Extrusion force क्या होता था? Extrusion force होता था sigma f into a naught into ln of a naught by af, isn't it? Now we have seen that this is the extrusion ratio. This is the extrusion ratio. So extrusion force is depending upon the extrusion ratio. It is correct. Next is what type of extrusion process. Definitely, we have seen that if there is a forward or the direct extrusion process is there. Suppose this is a direct extrusion process. So we have seen that force in the direct extrusion process and force in the indirect extrusion process. Suppose this is Fi. So we have seen that force in the direct is greater than force in the indirect extrusion, isn't it? So what we have seen that extrusion process, if there is a different extrusion process, so for that reason I will be getting a different forces, isn't it? So if this is also the type of extrusion process, definitely extrusion force depends upon the extrusion processes, whether it is a direct or whether it is a indirect. Okay, now see here what we can say. This is also true. Next is what? Material of the die. Now see, we have not seen anything about the material of the die, and we have seen that if my working temperature will be more, then definitely extrusion में फर्क पड़ता है. And for these things we have seen, and option C would be the correct answer. Now see here, there is a concept. There is a concept. Let me give you the concept of degree. Just a minute. Degree of drawing. Degree of drawing. This is also known as reduction factor. Reduction factor in cross-sectional area. So this is the degree of drawing we are saying. Now see, what is the degree of drawing? This is nothing but a naught minus of af by af. We have seen these things, right? That is nothing but pi by 4 d naught square minus of pi by 4 df square by pi by 4 d naught square. So if that is the case, d will be coming around d naught square minus of df square by d naught square. Clear? So this is nothing degree of drawing. So degree of drawing is nothing but this is denoted by d, and this is the degree of drawing, right? Now see, if you would write this degree of drawing in terms of true strain, right? So this is a true strain, that is epsilon t. This is nothing but ln of a naught by af, and when you will be substituting these things, you will be understanding this is ln by 1 minus of 1 minus of 1 by d. Okay, 1 by 1 minus of d. This is the degree of drawing. This is the question which has been asked in 2006. Try to find the answer. Tell me the answer. What will be the answer in this case? what would be the answer in this case? In this case, they have been asked to find the degree of drawing. Okay, to find the degree of drawing. Please tell me the answer. Okay, so very good, Khyati, very good, very good. So this is the correct answer that you are telling, option C, है ना? मिहिर, निकुल, वेरी गुड, वेरी गुड, वेरी गुड. तो चीजें बहुत सिंपल हैं. वायर ड्राइंग के केस में बहुत ही सिंपल चीजें मैंने आपको बताया. And this is the last session that we have seen for the wire drawing and the extrusion processes. Okay, so I hope you have enjoyed this session, and if you have enjoyed this session, do like this video as well as share this video in your friend circle and in your peers, so that they can also be getting benefited. And if you want, if you're going for a plus subscription, then definitely, if you are subscribing this, use my code SIRVK, SIRVK, to get a 10% off, and you will be getting my personalized guidance program for the same. And my dear friend, this is the last session for the wire drawing and the extrusion. From the tomorrow onwards, we are going to see the sheet metal operations, and definitely we are going to solve lots and lots of questions also. We are going to see a lot of things also. And I hope your preparations for the gate and ESE are definitely going good. For the gate 2021, you are preparing very good. ठीक है, मैं आशा करता हूं कि आप अच्छे से प्रिपेयर कर रहे होंगे, and these videos are definitely helpful for you. Any doubt in this today's session, my dear friend? Any doubt? Please ask the doubt which are, please ask the doubt which are relevant to the topic. Okay, don't ask the intangible doubt, then I will not going to take that doubt. Okay, I'm not going to take that doubt. So Nikul, I am working in the Unacademy only. Any other thing? Chali. So I hope you have understood this session, and definitely take care. I'm ending the session.